Hello students, welcome to Cbse Tayari. I am your educator and today we will discuss class 10th science chapter 1, that is chemical reactions and equations. So let's get started with today's class. To begin with, we have studied in earlier classes about physical changes and chemical changes. And under chemical changes, we have studied that chemical reactions occur that results in the formation of a new product. For example, burning of LPGs. Today, we will be elaborating on these chemical reactions that bring about the chemical changes. So, let's start. What is a chemical reaction? A chemical reaction is a process in which two substances are converted or changed to form one or more different substances. That is, a chemical reaction basically can be divided into two parts, that is, the reactants and the products. In this case, we have written one or more substances that will be getting converted. This one or more substances that are being converted, these are known as the reactants, and the new substances that are formed as a result of this conversion is known as product. It is written that the changes that is brought cannot be reversed by means of any physical method. What does this mean? This means that the new substance, that is the product formed, cannot be converted to the initial substance, that is the reactants that got converted to result in the formation of products. In other words, we can also say that the nature and the identity of the initial substance, that is the reactants, will get changed. Right? So, how can we determine that a chemical reaction has occurred? To determine how a chemical reaction has occurred, we have four criteria. One is the change in state. What is this change in state? This change in state means that the initial substance, that is the reactant, and the final product might be different in state. That is, the reactant might be a solid, and after the reaction has occurred and the product formed, this solid has been converted to a liquid. Similarly, change in color. That is, in the beginning, let's take an example that in the beginning of a reaction, the reactant was blue in color, and after the reaction has occurred, the product we got is white in color. This means the change in color is due to the chemical reaction that has occurred. Similarly, change in temperature and release of gases are also criteria that help us determine about the chemical reaction. The change in temperature, this criteria we will be studying further in the slides. Now, let's learn about what are the chemical reactions that we see in our daily life. First, let's take an example that in a very hot summer day, unboiled milk is left at room temperature. After few hours, we see this milk has been converted into curd. What is this? This means that a chemical reaction has occurred that caused the milk to be transformed into that of curd. Similarly, if we leave an iron pan or nail that is exposed to humid atmosphere, we observe that the rusting of the iron has occurred, and this is due to a process which is known as oxidation reaction, which again we will be studying in the further slides. And a type of chemical reactions that occurs every day in our body is the digestion of food, That is, the food we intake is getting digested by the enzymatic activities. This also falls under a chemical reaction. I hope if someone asks you about chemical reaction that occurs in daily life, you will be able to understand and explain them now. What are chemical equations? See, we have learned that about chemical reactions, but this chemical reactions is represented with the help of something, and this something is known as a chemical equation. Okay, so what is this chemical equation? This chemical equation basically depicts use of symbols of the substance that is taking part in the reaction and the physical state of the substance. For example, here we have mentioned our magnesium plus oxygen gives you magnesium oxide. Here in this equation, this magnesium and oxygen are examples of the reactants that are converted into magnesium oxide. This magnesium oxide is the product form. There are certain rules in a chemical equation. Let's learn about that. The first one is the reactants will always be on the left hand side. That is, in this case, it is the magnesium and the oxygen that are the reactants and they are on the left hand side. Similarly, the product, that is the magnesium oxide that is formed, is on the right hand side, and we use a arrow that depicts, this arrow depicts the direction at which the chemical reaction is occurring. Number 2 criteria is a equation should always be balanced. We cannot keep a chemical equation unbalanced. In this case, we have a equation that is magnesium plus oxygen forms magnesium oxide. This is an unbalanced equation. We cannot have an unbalanced equation. Why so? Because according to law of conservation of mass, a matter can neither be created nor be destroyed in that of a chemical reaction. Also, in a chemical reaction, we count and compare the number of atoms of each element on both sides. That is, we count and compare the number of atoms of the reactant and that of the product, and they have to be equal. Now, there are two basic steps by which we write or depict a chemical equation. First is writing a chemical equation, and the second is the most important one, that is balancing of chemical equation. As I have already discussed earlier, a chemical equation cannot be unbalanced, so it needs to be balanced. So in the further slides, we'll learn about it. So first, let's learn about the writing of a chemical equation. A chemical equation is always written by the name of the element, that is Zn. That is zinc. We write it by the chemical formula Zn. H2, H here is the hydrogen. Similarly, all the equations must be written in that of the symbols of the substance. And second, foremost important is balancing of this chemical equation. What is this? That is the product formed should always have equal number of atoms as compared to that of the reactants. How do we balance an equation? Let's learn about that. Let's take the example of the first one where Zn, that is zinc, is reacting with H2SO4 to give ZnSO4 plus H2. Here Zn is 1 in the reactant, and similarly in the case of product Zn is also 1. Let's see about hydrogen. Hydrogen here is 2. Similarly in the product also it is 2. SO4 here is S is 1, S here is also 1, and oxygen here is 4, oxygen here is 4. Thus we can say this equation is a balanced one. That is, that of the reactant and that of the product form is both similar. Now, let's learn about how to balance a chemical equation. In this case, we have in the reactant side Fe is 1, whereas in that of the product, we see that Fe is 3. Similarly, hydrogen here is 2 and in the product is also 2. However, in this case, the oxygen here is 1 and oxygen here is 4. Thus, this is an unbalanced equation and we need to balance it. How do we balance it? For balancing, first we keep it in a box. That is, the change can only be done at the outside of the box and not inside. So, in the product we have Fe is 3 and here we have Fe is 1. So, what we'll do? We'll multiply it with 3. We'll multiply with 3. Thus, Fe here is balanced. Now, we have to balance this oxygen. Oxygen here is 1 whereas oxygen in the product is 4. So, what do? We multiply oxygen with 4. So, oxygen gets balanced. However, after we do this, the hydrogen here gets unbalanced because here it happens that the hydrogen here becomes 8. However, in the product, we see the hydrogen is only 2. So, what do? We add, that is, we multiply this hydrogen with 4. As a result, we see that this equation, that is, this above equation that was unbalanced, and after balancing, this equations become 3Fe plus 4H2O gives you Fe3O4 plus 4H2. This is the balanced equation. Now, as I have already discussed that a chemical equation also gives you about the physical state of the reaction. That is, if the reactant is solid or liquid or gas, and similarly the product form is either solid, liquid or gas. So, in this case, we will also have to write which is what. Here, F in this equation, Fe is S, solid, Fe is solid, H2, that is water, is liquid. In the product, this is also solid, however, hydrogen is gas. This is what a chemical equation depicts. That is, first it will have the balancing of the atoms, and the second one is the physical state of the reaction. Let's go back, and we had an unbalanced equation. Let's balance that as well. In this case, that is this unbalanced equation, we see Mg is 1. Here Mg is also 1. However, oxygen is 2, whereas the oxygen here is 1. So, what do we do in this case? We add a 2 here. So, the oxygen gets balanced. However, the Mg, that is magnesium, gets unbalanced. So, what do we do in this case? We go and add 2, that is multiply 1 Mg with 2, and that's how we balance this equation as 2 Mg plus H2 gives you 2 MgO, that is 2 atoms of magnesium plus oxygen will give you magnesium oxide 2. I hope you have understood about the balancing of a chemical reaction. This balancing of a chemical reaction is a very important topic, and this is something you need to keep on practicing to keep a hand on it, because this is a topic from which majority of the questions are asked. So, let's get going with the types of chemical reactions. Chemical reactions is basically involving the breaking and making of bonds between atoms to produce new substance. That is, the reactants that were getting converted, how are they getting converted? They are getting converted by breaking and making of bonds of atoms to form the product. And this making and breaking of bonds of atoms to form new substances can be categorized into 5 types. One is the combination, then is the decomposition, then is the displacement, then is the double displacement, and finally the oxidation and reduction. So let's learn about all these types in the further slides individually with examples. First is the combination reaction. What is a combination reaction? A combination reaction is a one in which two or more compounds will react and combine to form a simple product. That is, we can say that, for example, if we take A is reacting with B to form AB, this is an example of a combination reaction. That is, one or more reactants will combine to form a single product. That is, A plus B reacts to form AB. Similarly, let's understand with the help of an example. Here we take the example of calcium oxide that reacts with water to produce calcium hydroxide and release a large amount of heat. This large amount of heat that is released also can be said that this is an example of that of a exothermic reaction. What is exothermic reaction? That is, a heat is released along with the formation of product. We will learn about exothermic reaction again after a few slides. In this case, the calcium oxide and water, they combine to form a single product that is known as calcium hydroxide, and this reaction is known as the combination reaction. I hope this is clear. Let's move on to the next one, that is decomposition reaction. That is, in this reaction what happens? A compound will split into two or more substances to form a new substance. For example, we can say that in decomposition reaction, for example, there is a product reactant that is A. This will split into A plus B. That is, this reactant will further go and split into two more substances to form the product. This decomposition reaction we can explain with the, for example, FeSO4 plus heat gives you Fe2O3 plus SO2 plus SO3. That in this reaction we observe that a single reactant breaks down to give simpler products, and this products that is a single reactant will breaking down to form three simpler products. This is known as decomposition reaction. We can further divide this decomposition reaction into 3 types, that is the thermal reaction, the second is the electrolytic reaction, and the third is the photolytic reaction. What is thermal reaction? Thermal reaction, as the name indicates, is a decomposition reaction that is carried out with the help of heat. Similarly, electrolytic reaction is a decomposition reaction that is carried out by the passing of electricity. And photolytic reaction is decomposition reaction that is occurring in the presence of sunlight. This mechanism of photolytic reaction is the one that is used in case of black and white photographs. Okay, let's go forward. Second, the third one is the displacement reaction. As the name suggests, displacement. In way, this means more reactive elements will easily displace, that is remove, less reactive elements from its solution. Let's understand this by this example, that is Fe, that is iron, plus CuSO4, that is copper sulfate, will result in the formation of iron sulfate and copper. What is happening? Iron is more reactive as compared to that of copper. So, as a result, from the copper sulfate solution, iron has reacted and removed the copper completely and formed copper sulfate, and the iron is separated and removed. This is known as displacement reaction. Similarly, is observed in case of zinc, where zinc and copper sulfate reacts to form zinc sulfate and copper. Zinc is also more reactive as that of copper, thus it has removed or displaced the less reactive element from the solution. Let's learn about double displacement reaction. What is this double displacement reaction? This is a reaction in which new compounds are formed by mutual exchange of ions between two compounds. That is, two compounds, that is the reactants, might involve in a mutual exchange. That is, we can say that A, B plus Cd will form Cb plus Ad. What does this mean? This means we will understand this with the help of this example. In this example, we have sodium sulfate plus barium chloride that results in the formation of product barium sulfate and sodium chloride. In the products, what we had? We had sodium sulfate and barium chloride. So, and in the results, what we have? We have barium sulfate plus sodium chloride. That is, the chloride from the barium chloride has gone and attached mutually to that of sodium chloride, and the sulfate from the sodium sulfate has gone and exchanged with that of the barium chloride to form barium sulfate. This is an example of double displacement reaction, and in this reaction a white substance which is insoluble is formed, and this is known as precipitate, and this reaction is known as precipitation reaction. What is a precipitate? A precipitate is something that is not soluble and will not easily dissolve with that of the solution, that will segregate. For example, if we take water and add sand to it and store it and keep it after for half an hour, what we see? We see two layers have been divided. The sand has been settled down and above it we have the water. What is this sand? This sand is the precipitate, and similarly the upper part is the water. This means that the sand is not soluble in the water. Similarly, the white substance which is formed is insoluble in water, and this is known as the precipitate. This white precipitate is formed by the reaction of SO4 and Da+. Okay? And again, if someone asks you what a double displacement reaction is, it is a reaction in which there is an exchange of ion between the reactants, and that results in the formation of new compounds. Okay? And the last one is, oxidation and reduction. What is oxidation? Oxidation is addition of oxygen and removal of hydrogen. A substance when gains oxygen, it is said to be oxidized. Similarly, if a substance loses oxygen, it is said to be reduced. Let us understand what is this oxidation and reduction. Oxidation is addition of oxygen and removal of hydrogen, and reduction is completely opposite to that of oxidation. That is addition of hydrogen and removal of oxygen. In this example, we have Cu plus oxygen to give you CuO. Okay, what happens in this case is in Cu we see addition of oxygen, and addition of oxygen is known as, yes, you are right, it is oxidation. And in the second equation we see that copper plus CuO plus H2 will give you Cu plus H2O. In this case, CuO, and in the product it is just Cu. This means oxygen is getting removed, and the process where we lose oxygen, it is known as reduction. And similarly here in the same equation, H2 and it is in the reactant, however in the product it is H2O. This means oxygen is added. So this is an example of oxidation. Again, oxidation is a process where addition of oxygen occurs and removal of hydrogen, and reduction is complete opposite to that of oxidation, that is addition of hydrogen and removal of oxygen. We can say in the above reaction, that is CuO plus H2 gives you Cu plus H2O. In this, one reactant is getting oxidized and the other is getting reduced. Such reaction is an example of oxidation reduction reaction, or other we can also say this reaction as redox reaction. Okay. As I have already mentioned that chemical reactions on the basis of temperature, that is change of temperature, can also be divided into two types, that is exothermic and endothermic. Exothermic, what is this? Exothermic is the one where heat is released during the production of product or with the along with the product. What is an exothermic reaction? Exothermic reaction is a one where heat is released, and we have already seen in the first one, that is in the combination reaction, that heat was getting released. So that is an example of exothermic reaction. Other examples is burning of natural gases. In burning of natural gases like methane, methane in the presence of oxygen results in the formation of carbon dioxide, water and a large amount of heat. This large amount of heat is when it is produced with that of the simpler product, it is known as exothermic reaction. And endothermic reaction. Endothermic reaction, on the contrary, is the one that requires energy in the form of heat, light or electricity. It requires energy in the form of heat, light and electricity. And the example for this can be, yes, you are right, the three types of decomposition reaction, that is the thermal reaction, electrolytic reaction and the photolytic reaction. In the thermal reaction, we needed heat. In the electrolytic reaction, we needed electricity, and in the photolytic reaction, we needed sunlight for carrying out the reactions. Thus, On the basis of temperature, a chemical reaction can be divided into two types. One is the exothermic and another is the endothermic reaction. Exothermic, release of heat, whereas in endothermic requires energy in the form of heat, light or electricity. I hope this is clear. Now let's learn about the effects of oxidation. Oxidation has brought about two types of effects in our everyday life. One is corrosion and the second is that of rancidity. Corrosion. What is corrosion? Corrosion is when metals exposed to moisture, iron or water, it is getting oxidized. What does oxidation mean? Addition of oxygen, removal of hydrogen. That is, when a metal, when exposed to moisture, air or water, a layer of oxides are formed. This oxides causes the weakening of the metal, and thus the metal is said to be corroded. What is the example of corrosion? Yes, that is the rusting of iron. That is, if we keep a iron nail or a pan exposed to that of humidity, we see that the iron is getting rusted. Why is it getting rusted? Because a layer of oxides are getting formed and that causes the weakening of the metal. Similarly, what is rancidity? Rancidity is oxidation of fat and oil. This fat and oil, when exposed to air, that it gets oxidized. As a result of this oxidation, bad smell and bad taste in food occurs. This is known as rancidity. Thank you so much. We have come to the end of this today's class. Thank you for being patient. I hope you have understood all the topics that have been discussed. With this, the chapter 1 of science comes to an end. Meet you in the next class. It was good having you around. Thank you.